All right, so for fun, P-H-U-N, so much fun, we had to spell it with a P-H. We're gonna classify the triangle by angle and side. So remember we were doing this earlier, almost just kind of a quick review, is verify triangle inequality. Must do that first, because I will tell you, we will try to trick you. All right, so that's where the A plus B, the two smaller sides, must add up to be greater than the third. So in this case right here, we get 4 plus 5 equals 9, bigger than 7. So check, we can make a triangle. All right, step 2 is, well, that's embarrassing. I had step 2 and wrote 3, is plug it into Pythagorean theorem. All right, so that means that we're going to do a squared plus b squared equals c squared. So 4 squared plus 5 squared. Now, I don't want to write equals. I'm just going to write 4 squared, 5 squared, and I'm going to compare it to 7 squared, and I'm going to see what happens. So we're going to get 16 plus 25, which equals 41. 7 squared is 49. So it's not equal. Not equal, then it does not make a right triangle, because Pythagorean theorem only works for right triangles. And some things we just need to remember is that since c squared, so we even write this out, since a squared plus b squared was less than c squared, it's obtuse. That's a rule you have to remember. All right. And then, so we can classify this triangle. None of the side lengths were the same, so it's scalene, and then we figured out it was obtuse. Okay, cool. Scalene, obtuse. Do the same thing for this one. Is verify triangle inequality theorem. So I'm not going to write out as much as I did last time. All I'm going to do is 9 plus 6, which is 15, bigger than 14. So it can make a triangle. Cool. 2 is I'm going to plug in this to Pythagorean theorem. So 9 squared plus 6 squared. I'm not going to write equals quite yet. I'm just going to solve it and compare. All right. So 81 plus 36. It's 117. This down here gives you 196. So that is greater than. So using the rule we talked about before, it's, again, this is the same classification actually. Scalene, obtuse. If 2 sides were the same, it would be isosceles. If 3 sides are the same, it would be equilateral. And let's make a little side note. If a squared plus b squared is greater than c squared, then that's a case where it's acute. We're not going to see that though in this one. Because then we got this last one. Again, verify that triangle inequality theorem works. 5 plus 5 equals 10. 10 is bigger than 10. That is simply not true. So, not a triangle. Not a triangle. Maybe we'll put a smiley face because you guys are sick of triangles at this point. All right, so just a little quick review of the classifying triangles, just given 3 side lengths. Without even seeing the actual triangle, you can classify by angles and sides. We saw 2 obtuse ones. We kind of reviewed what it looked like for acute. If Pythagorean theorem works, it is a right triangle. And then you just classify it by sides by looking at the sides themselves. And then we're going to do a quick transformation review. So we're going to apply the rule XY, arrow x minus 1, y minus 2. So a quick review is when you see a coordinate rule with addition / subtraction, that's a translation. All right, translation is addition and subtraction. All right, so to do this first one, we're going to go left 1, down 2. All right, so left 1, down 2, left 1, down 2. So this is going to be P prime, Q prime. And we even write out the coordinates. That is 0, 4 and 6, 0. All right. And we'll even circle that one right here. Then when we see multiplication, so 0.5 times x, 0.5 times y, multiplying by a fraction, multiplying by a decimal, multiplying by a number bigger than 1, whatever that might be, that's dilation. That's when we multiply. All right, so that means I'm just going to take my existing points and multiply everything by 0.5 or 1/2, or you can think of even dividing by 2. So 0 times 0.5 is 0, 4 times 0.5 is 2. So boom, it's going to go there. And then Q prime, excuse me, will go to 3, 0 after I do the dilation. All right, so then I have P double prime, which is now at 0, 2. And then Q double prime, which is now at 3, 0. And the last thing we're going to do is reflect over the line. Here, I'll even circle that. We're going to reflect over the line y equals 2. And it's really just counting. All right, remember this is the line y equals 2. So since P double prime falls on that, P triple prime, our final one, will fall right there as well. And I'll even write P triple prime over here. It's still 0, 2. And then Q triple prime, a little bit more calculations, it's 2 below the line. So it's going to be 2 above, boom. That's Q triple prime. And that's going to land at 3, 4. All right, so just a quick review. Remember, all of these stuff, we do these quick little reviews because they come back later on. They're going to help keep stuff fresh in your brain and really help you succeed on future stuff. All right, that's it. Have a good